Next up, we have Sam Green, co-founder of Semiotic Labs and core contributor to the Graph. Excited to hear this. Real-time data improvements in the Graph. Let's go.
Thank you.
Thank you.
Hey, everyone. Thanks for sticking around later in the afternoon. My name is Sam Green. I am a co-founder and the head of research at Semiotic Labs. Semiotic is one of the 8 core developers of the Graph protocol. So the Graph is, we're decentralization maxis. Everything that we build is built by 8 separate independent projects. We all specialize in different things. And Semiotic specializes in AI and verifiability. But today I'm going to be representing the Graph, and I'm going to be highlighting some of the performance improvements that we've been making to the protocol. And so I'll be introducing the Graph. I'll then talk about some new technology that we're developing called Firehose and substreams. I'll then share with you some early prototypes that we have built for high-performance SQL queries that we will be bringing to the Graph, and then I'll give you a little more information for getting involved. At a high level, when you look at a blockchain and you look what's coming out, you have a bunch of transactions. Those transactions have all sorts of details, and those details are hard to get to unless you start hacking, if you hack at the raw data. And the Graph organizes that data, and it makes it easy to query the data. And that's what the protocol does. And if you look more closely, we're doing extraction, transformation, loading, and querying. So what you see here is our current stack, or our V1 stack, where at the extraction layer, you had JSON RPC polling of archive nodes, and then you transform that raw data with assembly script, which is like JavaScript. And then those transformations get loaded into a Postgres database, and then you query it with GraphQL. So what we're doing here, by the way, why you want these steps is that we are collecting data and transforming data in a way that wouldn't make sense to do on-chain. So for example, if you wanted to calculate the total volume being swapped on Uniswap, you don't want to track those numbers in a smart contract. You would go broke. And so we do these transformations off-chain, and we do it in a verifiable way. The protocol powers most of the major dApps. So for example, if you go to info.uniswap.com and you look at the pricing information there, all of that data is coming from the Graph. A few months ago, we passed the 1 trillion query mark, so we're serving a lot of data every day. And now getting into some of the performance advancements we've been making. So the Uniswap subgraph used to take several months to index if you start from the beginning of when Uniswap was launched. And now with this new technology we got it down to 20 hours. And I'll explain I'll be explaining this stack. Our V1 stack looked like this. You have a blockchain node that is queried that's being tracked by an archive node. And that archive node is putting all of the transaction details into a database. And then we have a piece of software called GraphNode that queries the archive node, and then based on what the transformations that you want to extract, puts that information into a Postgres database. And the GraphNode also accepts GraphQL queries, transforms those GraphQL queries to SQL to query the database, gets the result for you, and sends it back to the consumer. Most consumers these days are front ends, dApps. Now I'm going to introduce Firehose, which is a new technology that was built by one of the Graph's core devs, another Graph core dev called Streaming Fast. Streaming Fast is exclusively for extracting data from the blockchain, and it puts that data into flat files. And as a summary, what we do with Firehose is we have a single data framework for all blockchains. So the Graph supports many blockchains today, and we're going to support all major blockchains. And this technology can run on a single server, or you can run it at enterprise scale. And its main job is to extract transactions and events from the raw blockchain data. And we're using protocol buffers for our file format. We also call those flat files. And flat files are nice because they're language neutral and they work across all platforms and they're extensible. Also, everything that the graph does is open source, and you can use the graph software stack for your own projects, or you can come and participate in the graph protocol itself. And at the end, the fire hose is simply providing a raw pipe of data from the blockchains that it supports. And it works with Ethereum-like and non-Ethereum-like blockchains. So why do we need something like Firehose? Well, if you are trying to access data, if you're trying to build something that's based on multi-chain data, you're going to have to track reorgs, hard forks. All the chains may work in different ways, and different chains don't have common APIs. So if you were doing this yourself, you have a lot of custom work that you're going to have to do to extract the data from each chain that you're interested in. And Firehose abstracts all of these steps for you, and its output provides a common API that you can just access. Our V1 stack was built on RPC nodes, so you had to make RPC queries to the archive node to get the data. That was not fast enough. That's why it took us a few months to sync Uniswap. And the new solution just dumps everything into these flat files, which can be read very efficiently, and we get rid of the RPC requirement. If you were to run the Firehose stack, you would see that it's creating a bunch of files. Each of these files is a binary format file that's just storing the raw blockchain data. The architecture of Firehose is that you need a full node, not an archive node. So you have a very light node requirement, and you may need a consensus layer client if the chain requires it, and then you need the Firehose binary. And we provide binaries for Ethereum, Cosmos, Arweave, and others. Okay, so now we have this raw data, all this raw data, and that's probably not going to be useful in itself. You probably would care about some aspect of the raw data. You want to filter the raw data, and that's what substreams do. So substreams read from those Firehose flat files, efficiently extracts the information, and does transformations if you need to do transformations on that data. Substreams modules are composable, so if you write one of these substreams filters, you can then compose the output and write another substream module that takes the previous one's input. You can also parameterize it, so let's say you want to do something to one contract, and then somebody, let's say, forks that contract, and you want to do it to a new contract. Substreams makes it easy to do that. You can also still do transformations like tracking TVL or other things that you don't want to keep on chain. It's also parallelizable, so it can read from all these flat files in parallel. The substreams, if you want to write substreams, you write it in Rust. The Rust gets compiled to WASM. That WASM then gets sent to a substreams engine that sits next to the flat files and can efficiently read from that data, read all that flat file data. So here's what we have so far in the new stack. We have Firehose, which extracts the raw blockchain data for all of these chains, well, every chain that you're interested in. You have substreams that transform this raw data. You can then, what I'm about to go into now is what you can do with that extracted data. And we say that you sync that data somewhere that you would be interested in using it. And then finally, you have a query layer where you make requests for the data that you're interested in. Today, we have integrated substreams into our main stack. We now have substreams-powered subgraphs. And so far, or some major ones we have are Uniswap, Balancer, and PancakeSwap. PancakeSwap is notorious. It runs on BNB, and so I think we're the only solution that can handle indexing that DEX right now. The architecture of the Firehose stack looks a little bit different. You have a Firehose-enabled blockchain node. This is a full node, like I said, so you don't have all of that extra overhead. You don't have to sync an archive node to run the Firehose stack. The Firehose-enabled node outputs the flat files, and then that gets fed into a substream service, and then the output of the substream service gets sent to a sink. And the sink can be something like a graph node, it can be a database, or you can just stream the data out in real time. So now what we have, so this is what we have so far in the graph. We basically have two stacks in the graph. We have the V1 stack and we have the Firehose enabled stack. On the left-hand side, we have the extraction layer. Today that would be graph node and Firehose. And if you want to use these tools, you need ops expertise. If you want to use Firehose and run Firehose yourself, you need ops expertise. Of course, the graph and the participants in the graph run this infra for you if you don't want to run it. If you want to filter the data, then you'll write assembly script or Rust. Assembly script if you're targeting GraphQL, and Rust if you're targeting anything else. And then finally, you have the query layer, and that's what most consumers are going to be using. They're just going to be wanting the extracted data for their application that they're using. And today, in the graph, we support GraphQL as the only query type. But that's going to change. So what does this new technology stack mean for the graph? Today, the graph is awesome for dApps. Most major dApps get their information from the graph. And in the future, you're going to see a lot more data. So when I talked about syncing the substream output, I said that you can sync it wherever you want. And we see that there are many places that you could put the data that would be interesting to use. And so soon, so now we're transitioning more to what Semiotic is working on right now with this stack. Soon, within the graph protocol, you're going to be able to make SQL queries, so you'll be able to do analytics with the graph. And the way that's going to look like is you're going to have Firehose and substreams, of course, and then the substreams output will be synced to some sort of high-performance database, and then you'll be able to query that high-performance database with SQL through the protocol. Here are some numbers from some experiments that we've been running. With the solution that we made, we can sync all Uniswap v2 events in 4 hours. So this is from when Uniswap was launched. We can get all ERC20 events on Ethereum in 12 hours, and we can get the metadata related to all transaction and blocks in 19 hours. So I believe that this is I don't think there's any other solution out there that can provide this sort of performance. So we have all this data, and specifically we have synced all Ethereum v2 and v2 clones to using this stack. All Uniswap v2 and v2 clones on Ethereum to our database. Initially, we synced it to a Postgres database, which is what our current v1 stack is based on. And then we also synced it to ClickHouse, which is a database that's good for analytics. And here are some numbers that you can see for some questions. So all these questions that you're looking at, we converted them to SQL, because I don't want to be showing SQL. And we ran that SQL, and you can see on the right-hand column that we can answer these various analytics questions very quickly. For example, what addresses bought the most ETH last month but did not sell any? That takes 14 seconds. What token has had the lowest USD volatility during the past 24 hours? Takes 3 seconds, and so on. Okay, so I told you that I converted those questions to SQL, but I didn't tell you how. So we're also prototyping using natural language to convert, using large language models to convert natural language to SQL. And of course, natural language would be the ultimate in terms of usability to access for general access to data for UX. The way that would look like is everything would be very similar, except at the query layer. At the query layer, you would have natural language, of course. Here's an example from the prototype that we built. Plot the average daily price of ETH during the last week. So we have a prototype now that is tracking Ethereum. It's up to Chainhead for Uniswap v2 and all its clones using the graph stack. And you could submit a natural language question to our prototype, and you can get the information. So this is all, all this is built on the graph stack. So what this means is that today, of course, the graph serves GraphQL queries. In the future, we're going to also serve high-performance SQL queries for analytics use cases. And we're also going to be bringing large language models to the protocol. And what's probably going to happen is we're going to have, currently our indexers specialize in serving GraphQL, but our indexers are going to probably begin differentiating. So some indexers will specialize in serving high-performance analytics data. Some indexers will specialize in serving open source large language models. And this is going to, of course, increase the market that the graph can serve. And it will increase the types of customers that we can serve. In summary, the graph found product market fit with subgraphs. If you've heard the word subgraph, it was invented by the graph. We've recently made indexing 50 times faster than our V1 stack. We're doing that using Firehose. Firehose extracts raw blockchain data and puts it into flat files. And those flat files can be filtered very quickly with substreams. And the substream output can be put wherever you want. Semiotic is currently focused on putting the substream output into an analytics database and using that to drive our knowledge of how to bring that to the protocol. And I focused on SQL today and natural language, but there will be many other data services that you're going to be hearing about soon, and the Graph Foundation will be making an announcement about that soon. This link right here is probably, if you want to start using this tech, probably the easiest thing to do is just use our Firehose files, and don't worry about running that part of the stack, although you can. It's, like I said, it's open source, Apache 2. I would recommend just starting to play with substreams, and you can do that. There's a getting started guide at that top link. Semiotic is currently hiring, so if you're interested in these sorts of topics, we are currently looking for a back-end developer, and they can be remote in the Americas or here in the Bay Area at our office in Los Altos. And today I was mainly talking about data, a little bit about natural language, but one of the other things that Semiotic is interested in, and we do, is build agents. And we're curious and interested in improving the Web3 UX using all of this technology that we're building. And tonight we're going to have an event. We have, I think, maybe 20 spots open. And if you're interested, there's a QR link to the event. And we're going to have basically pizza at 6, and then we'll have some lightning talks for an hour. We'll have talks from Flashbots, the Ethereum Foundation, Odos, and 7X Ventures. And we'll be talking about the future of Web3 UX. So that's all I have. Thank you.
Do you want to take any questions?
Sure. Yeah, if anybody has any questions, I'm happy to answer them. So the question was, I'm curious what your infra cost is and what your revenue is. Okay, so the graph is decentralized in the sense that not only are the builders of the graph from different projects, but also the participants in the protocol. So the people who are running Firehose, they're all independent entities. Some of them may be on GCP, some of them may be on bare metal. So it varies from, it'll vary. Some of them will do like a small scale operation. Some of them will do large scale operations. And the other, your question was about cost. So the cost is going to vary all over the place. And what was the other? Oh, the revenue. So the revenue of the query fees in the graph, there is a website that tracks a Web3 revenue. I can't remember the name. Web3, if you search for Web3 index, that tracks revenue of many decentralized projects. You're welcome. Any other questions? The question was, can existing subgraphs use these performance enhancements? The answer is not today. But we know we have, I don't know how many tens of thousands of subgraphs deployed. And so we're talking about how can we port these subgraphs over so that it can use this new stack. So this is maybe if you just stay tuned, because we know that people want to do this. So we just need to figure out how to map them over. Of course, it's important. Anyone else? Okay, thank you.
Awesome. Big round of applause for